My name is Deep. I work as a Gen AI architect, and I work for a consulting company. And what we do actually, we build enterprise scale agentic AI systems for large scale enterprise. So this is one of the use cases that we build for a large telecom client, and the system is in production, in live, like right now. And what I wanted to talk about is what is the architecture, what are the decisions we took, and what kind of lessons that others can also use from our experience. All right, so this is the agenda that I'm going to go through. I'm going to describe what actually the problem was. I'm going to talk about the architecture. We use a multi-agent system architecture using LangGraph. And there were many agents built. We'll do a couple of agent deep dives and how we used it in our system. Then we're going to walk through a query, an end-to-end query. So what happens when someone calls this system? And also the key takeaways from our multi-agent the key takeaways from our multi-agent system architecture. So as I mentioned, we built this solution for a big US large telecom enterprise. And we built it for their field operations team. Now, if you see who are actually these field operations people, they are like field technicians. So these are the ones who installs and repairs and visit our houses to install new internet service, cable, phone lines, etc. We have construction engineers. These are the ones who actually lay off the cables. They lay the cables, who maintain the infrastructure. And then we have maintenance engineer who performs the fault, who diagnoses the fault and performs repairs. And all these three technicians, engineers, construction and maintenance engineers, they also have the field supervisors who manages each of these different verticals. Now, the thing that we saw is there are shared pain points across all these different groups of people in the field operations unit. So one of the most important things is that, so whenever a field technician comes to people's house, they don't have a real-time job context. All they get is kind of the job number, then the truck, then they get their routing information, then they visit a premise. And the customer history, equipment details, prior issues, they all lie in like separate systems, separate disconnected systems. Then we have fragmented tools and systems. One job requires for a technician to log into multiple systems to get the context of the whole history of what's going on. Then also, there's like inconsistent troubleshooting quality. There's no standardized guidance. So there's a big difference between someone who has been working in the field for like 2 to 5 years and someone who is working for 20 to 30 years. So the type of problems and experience field technician engineer have seen, and they can solve it pretty quickly. So there's no standard guidance that is given to them. So what we decided is, and there are a few other issues as well. So what we had a vision that we wanted to build an unified intelligent assistant to serve all these different groups of people in the operations team, whether it is field technicians, whether it's construction engineers, maintenance engineers, and their supervisors as well. So if you see before and after, so we tried to remove this disconnected systems and try to embed a single agentic AI chatbot into the existing mobile app. And we're going to talk about the architecture in the next slide. And when the technician logs in, now they get a live job context that's automatically on demand. You'll have AI guided like troubleshooting for everyone. And then also these are very region specific because in telecom, every region is different. The whole country is divided into multiple different regions and what kind of job a technician is doing. And the important thing is that they would get the real-time insights and BI reports. And these are actually mostly for the supervisor. So the point that I want to land here is that the answer wasn't just build a smarter search box. We wanted to build an intelligent agent system that understands this context and calls the right tools, right APIs, and delivers in one coherent solution. So if you look at the architecture, So this is a multi-agent system architecture. And the mobile application that technicians were using the Tech Mobile app, and for the supervisors, they use the Submobile app. And our second layer is what we built. We built using an open source framework called LangGraph. And the most important thing is the orchestration layer, where we need to find out the intent of the user query. Like, what is the question that a particular technician or supervisor is asking through their interface? So once we identify the intent, then the orchestration agent knows which agent to invoke. There's also something called RBAC, which is a role-based access control, because the type of information a technician can see would be very different than the construction engineer or a maintenance engineer and the supervisor. So the role-based access control, they control what information a particular persona can see. And the orchestrated agent gets the enriched profile, which is basically the role-based access control, and they get the context of who this person is, what is their ID, what type of information this agent can share. Then there are different ways to execute the agent. And then there's like single parallel, like sequential invoking of agents. And then once we get the response from the LLM, we need to synthesize it in a structured format. And I'm going to talk a little bit about the observability. For observability, we use something called LangFuse, which is also an open source framework, to know every single point an agent is making, a live decision. So we had like multiple agents that we built, and we're going to talk deep dive into a couple of agents, which is the job insight agent and the tech assist agent. And this is what we delivered for the phase 1 of our project. There's still other agents that we are still working on: inventory, BI agent, supervisor agent. And the generic chat agent is, so this is something like if you ask some random question to our Agentic AI chatbot, like what is the weather, it's going to reroute you saying that I can only answer questions related to specific like telecom plan. So, and our whole agent is deployed as a microservice in AWS Kubernetes and through REST API endpoints. So if you see, if we deep dive through one of the agents, which is, so this is one of our primary agents, which we call it like a job insight agent. So when a technician goes to the interface into the Tech Mobile app, they ask a job-related question or taps a particular, there's like a job insight button that they get. And when they tap it, they'll get the job ID number. And based on a job ID number, right, it invokes parallel API calls. So these are the tools that we built in our LangGraph system. There's different types of tools like Activation API, Chronicles, work order to get the truck roll history, like repair call summary, service details, etc. So these are all called in parallel using async. And so the first LLM call summarizes this raw API responses into a structured downstream summary. And there's another call goes to the LLM, which generates the final conversational answer using summary as a context. So, and all this chat history is saved into PostgreSQL, which is a database. And any follow-up questions that the technician is interacting with our system, we don't have to call the agent again. It is stored in the history, like without recalling all the APIs. So, and this is, I've just given a simple example of how many tokens we might use for one particular call, like around 1,500 tokens. And so this is, so the point that I'm trying to make here is that, so the APIs were already existed in the telecom enterprise. We're just using effectively as a tool in our system to call the right API based on the intent of the question that the technician is asking. So the next agent is again the tech assist agent. So for this, so this is related to any question a technician might have. So whenever they're at a particular house or a premise, they might have questions related to a modem or frequency. So these are questions that can be answered by the knowledge base. And for this, we are calling an external rack service. This external rack system was built by another partner team. So we are just using it as a tool in our agent. We haven't like rebuilt the whole rack service. So what happens is that any question, which intent of the question, which which might be due to device troubleshooting, LED diagnostics, etc. It calls this API, and we treat it as a black box tool since we didn't design this particular like rack service. So it gets the relevant documentation, source references, so the grounded on the actual company data, and the responses are generated by the LLM, and we have there's no risk of hallucination, etc., because this is a very grounded responses. These are anchored to the client's approved like technical documentation. And in a telecom company, there will be lots of technical documentations about network frequency, etc. So how does API calls? And we'll actually next slide we'll go through a whole end-to-end query. If someone is writing why is the red light blinking on the modem, and it identifies the intent of that particular question, and it fires the tech assist agent, which basically calls that API tool, and then we get the chunks and the source references, and then the LLM generates the final response. So one of the design principle is in large enterprises we cannot rebuild everything from scratch. We need to reuse what already exists, whether it is APIs, another service, etc. The important thing is that how do you orchestrate all these different APIs, different agents. So that is the final takeaway that I wanted to take away from this slide. So this is one of the examples of a query end-to-end. A technician comes to a house and asks a question, why, as I said, why this modem is having a red light. So technician sends this query to this chatbot UI. It goes to a REST endpoint, and we have authentication layer. It authenticates it is coming from the right technician. Then the orchestrator layer gets invoked, and this orchestrator layer, based on the question, it finds, okay, what should be the intent of this particular query. Then it finds out, okay, this is a device troubleshooting query. It routes to the field tech agent. Then we get some enriched profile, which is meaning we also have to know the, as I was mentioning before, whether it's a field technician, supervisor, because they get different information. So that's what the profile information comes on. And then the tech assist agent executes, then they get the right answer. And we're using for LLM, for this particular use case, we're using GPT-4o. All this chat turned, everything is saved into Postgres SQL, as I said, then the answer is delivered. So initially, in our initial testing for the new query, it might take, actually the timing is still improved on the latency. These were like old timing. It might take 2-3 seconds. And for subsequent queries, it will be in like milliseconds because every context is saved. And that's why we use LangGraph, because it maintains state management. Let's go to the next. All right. So these are the key takeaways I want people to take from our experience of building this production agentic AI system. First thing is that we need to make sure in large enterprises, we have to be secure, and we need to find out what is the intent of a particular agent, and giving role-based access controls so that we know what we are doing. So it has to be a little bit of like deterministic, because the answers should be reliable. Otherwise, big enterprises won't deploy large-scale AI systems in production. The hardest part is the orchestration layer, which also takes most of the tokens. We also have to make sure how much tokens we are using it. State management, context persistence. So that's where most of the tokens get used. And then third point, as I was mentioning before, we don't have to build everything from scratch. We need to reuse any APIs which are already in service in large enterprises. We just have to orchestrate, and agentic AI makes the current investments smarter. Then the observability, we have to make sure from day one we are able to see what our agentic system is doing. We use LangFuse, which is again an open source framework. We self-hosted this LangFuse in AWS, so that we can trace, and every single trace with every single span, we know the token cost, we know what LLM call this agent is doing, etc., etc. And then one other technical thing, initially we built using like WebSocket, we moved to REST because it was much more easier to manage like REST endpoints. Okay, so that's about it. So yeah, so this is my contact information. I would love to have If somebody has any questions.